Assalamualaikum and very good days. So we proceed for the next subtopic for the application of the vector value function. In the second application is a motion in the plane curve. Okay, so in this topic we will learn about how we can determine the position vector, velocity, speed, acceleration of the vector function. So if the given the vector, okay, the given the vector function here, rt equals something lah, ti plus cos tj, okay, plus k. Let's say the given the rt. So from this one you can determine for the velocity by differentiate the position vector. So you differentiate here, so you can determine the vector, determine the velocity. Okay, and then you differentiate again the vector function, so you can determine the acceleration. So this is the way lah how you can determine for the velocity and acceleration. So the rt you can determine vt and then get the at. Okay, so you differentiate here, you can get vt. You differentiate vt, you can get at. Okay, so for the vice versa, so you return back. If you return back, okay, you this one differentiate, so inverse of the differentiate is the integrate. So you integrate acceleration and then you can get velocity. You integrate velocity and then you can get position vector. Okay, so this one you integrate and then this one you differentiate. Okay, this is the way lah how you can determine for the velocity, speed and acceleration. Either the differentiate or integrate. That depend on the question. Okay, so rt here, you integrate vt, you can get rt. You integrate at, you can get vt. So this way more simple lah. More simple, you need to remember lah for the application. Okay, let's say we have the some example. Okay, Professor, speed. So if the speed, you need to magnitude the velocity. Okay, magnitude velocity. That's mean you kena set x component kuasa 2 plus y component I dah. You confuse lah x, y, z. Saya tukar This one you should know lah how to magnitude, because we already learned in the revision for the previous topic. Okay, so I, so component for the I square, component for the j square plus component for the k square. This is the way how you can determine for the speed. So kat sini bila dapat jawapan no more ijk, dah tak ada ijk dah, no more ijk. So no more ijk, dia give the value. So let's say this one t lah, t square plus cos square plus 1. Okay, so no more ijk here after you complete for the speed. Okay, this is the operator ataupun parameter that you can determine in the motion in a plane curve. Let's say we have the example. Okay, find velocity. Okay, acceleration and speed. Okay, and speed. Okay, so for the vector, given the vector is the rt equal set ti plus t square j plus exponent 2t. Okay, this is the question given for the vector value function. So they need to determine velocity. So you tahu lah velocity, so r prime t equal velocity t. So equal, so you differentiate here, so you akan dapat 1/2 set ti plus 2tj, okay, plus 2 kali 2 exponent 2t k. Okay, so this is the way how you can determine for the velocity, settle, and then find the acceleration. So acceleration, that means prime differentiate again, or v prime t, okay, differentiate here equal to at. So you differentiate here, you can, and then you can get negative 1 over 4 t 3 over 2, okay, 3 over 2 I plus this one differentiate, you can get 2 j, okay, and then differentiate, you can dapat 4 exponent 2 t k. Okay, so settle. This is the way how you can determine for the velocity, okay, velocity, acceleration, and speed. So speed so equal magnitude of the velocity. So magnitude of the velocity, so you only bring the component ni je, okay, ijk, no more ijk. So bukan acceleration, speed is the v, sorry, speed is the v, not a, bukan acceleration but v. So saya padam balik, sorry, okay. So you look at the v, okay, look at the v. So v here, so you dapat 1/2 sec t kuasa 2 plus 2t kuasa 2 plus exponent 2t kuasa 2. Okay, that's all. Ni kurungan nanti takut silap. Okay, that's all. So you akan dapat sec 1/4t plus 4t square plus 4 exponent 4t. Okay, so you just remain here. So let's say the question asking find velocity, acceleration, and speed at t equal 0. Let's say macam tu lah. Okay, so after that, you masukkan ni. So v, so this one you can v0, so you masukkan ni. Okay, so you can get lah a0, this example a0, so you masukkan t equal to 0. Okay, and then for speed you masukkan lah t equal to 0. Ni example lah, this one not possible lah, equal to 0, 1/0 you can undefine kan, maybe t must be equal to 1. Let's say t equal to 1, so you masukkan lah v1, and speed at t equal 1, so you masukkan t equal 1, and then you get the answer. Okay, this is the way lah, depend on question. Kalau question never mention ataupun listed for the t, for the certain t, so you just remain the answer like this. Okay, depend on the question, so you need to read the question properly lah. Okay, this one they given the vector function, so you need to find the velocity, acceleration, and speed. So how you can determine for the vector position, okay, vector position and velocity when the question given the acceleration. So you can return lah, draw back, patah balik. Okay, so let's say this question they given the acceleration. Okay, so a particle start at the origin, okay, with initial velocity is I tolak j plus 3k, okay, and its acceleration is AT equal 60i plus 12tj plus minus soalan given minus minus 60k. Okay, so this one expression. So the question, find 8 position. Okay, position function. Okay, find the position function. So that means the asking for the RT. Okay, the question ask for the RT ataupun position vector. Depend on question. So same meaning same meaning. Okay, so the given the AT. So you ingat balik tadi RT, so dia boleh jadi kepada VT, jadi kepada AT. Okay, so this one differentiate. So untuk get the RT you kena integrate. Return. Okay, integrate. So the question given the AT. So the given the AT. So the question asks for the RT. So you need to determine for the RT. So you need twice integrate. So integrate AT. So equal integrate 60i plus. So you boleh split lah senang. 12t j plus minus. You split all the integration. Minus integrate 60k. Okay, so you integrate here, so you can get 6t kuasa 2 per 2. Okay, 6t kuasa 2 per 2 plus C1 kan. So this one 12t kuasa 2 per 2 C2. Okay, this one minus 6t square per 2 plus C3. Okay, so they have the K, this one J, mana? This one they have the I. Okay, so you simplify 3t kuasa 2i plus 6t kuasa 2j minus 3t kuasa 2k plus C. Okay, C1 saya explain previously C1, C2, C3 you plus mana equal to single C. Okay, single C. And then you need to determine for the RT. Okay, so before you proceed to determine the RT, so you need to solve for the C. Okay, jangan you proceed dapat ni 60, so you directly integrate to determine for the AT. No, you just already find the VT, so you need to complete for the C. So how we can complete for the T? So you need to find the boundary, okay, ataupun initial condition. Okay, initial condition. So initial condition the given here, velocity, initial velocity. Okay, initial velocity that mean V the T equal to 0 sebab initial velocity. So V not equal I minus J minus 3. Okay, this is the initial velocity. So this one VT. So you masukkan VT equal 0. So you dapat 0, 0, 0 plus C. And you put equal 0 plus C. So C equal dengan here, you bawa here, C equal I minus J minus 3k. Okay, so you substitute C equal I plus J, so you can get 3t square I plus 6t square J minus 3t k. So ni number 1 ni A, so you kena plus C. C adalah I plus J plus 3k. So what happen if you have the vector A plus B, so I plus I, B, J plus J, K plus K. So you akan dapat 3 square plus 1 I, so plus 6 plus 1 J minus 3t square plus 1 K. Okay, so you can get this answer. After that, barulah you, so this one VT, so you dah selesaikan for the C, barulah you integrate for the VT to determine for the RT. So you integrate VT, so you can get RT. So your RT sama dengan so you integrate 3t kuasa 2 bagi 3, so you akan dapat t kuasa 3 plus t, so this one for the I, 3t kuasa 3, 2 lah, 2t kuasa 3 okay, 2t kuasa 3, 2t kuasa 3 dan 3 bagi 2, 2t kuasa 3 plus t j, okay, plus minus t kuasa 3 plus t lah. Okay, okay. So macam biasa, when you integrate ni kan, integrate here, so this one akan ada plus C, simple lah. Ni C1, C2, so simple, you just lastly you plus C saja. Okay, mudah. So you dah dapat this answer. So and then you need to solve for the C. So what is the initial condition for the C? Initial condition for C, they said here, a particle start at the origin. So bila start kat origin, that means R0 equal to 0. Okay, so when you substitute t equal to 0, semua jadi 0 kan, 0, 0. So C equal to 0. So your final answer is that RT equal 3 plus T I plus 2T 3 plus T J minus T kuasa 3 plus T. Okay, so this is your answer. So you kena be careful lah. If you want to, if the question given the acceleration like this and then determine for the position, so the another thing, the important thing, you need to find the initial condition. Okay, so you kena highlight lah, kena still always remember. Okay, for this step, kalau you tak nak lupa, so you remember for this step, if the integration here, so you need to find, determine for the initial condition. What? Okay, so this one you kena dapatkan equal to what? So this one they require to solve for the C. So here you need to be careful lah. Okay, you jangan direct integrate. No, you kena solve C dulu. Solve for the C and then barulah you dapat complete for the velocity, and then you integrate for the velocity, you get the RT, and then you solve for C, and then barulah you dapat complete for the RT. Okay, this is the way how you for the integration. Kalau differentiation tu senang, you differentiate saja. Okay, tak ada C, tapi integrate they have the C. When the integration contents of the C, so you need to find the initial condition. So initial condition, you need to read properly the question, either the given in the statement or the given in the equation. Sometimes the question given in equation, so dia dah bagi dah V not equal berapa-berapa. So let's say dia kata the RT equal AT equal 60 with V0 equal apa, R0 equal apa. Itu direct question lah. If the question indirect, so you need to find lah, based on the statement, which one is the V0, which one is the R0. Okay. Okay. So I already complete for the vector function application for the motion in the plane. Either they given the RT and then determine for the velocity and acceleration, or they given the question in the acceleration and you need to determine for the velocity or vector position. Okay, the last example. Okay, the last example. Find the velocity and acceleration particles with given position vector RT equal T square sin T tolak T cos T and cos T plus sin T. Okay, and the given T must be larger than 0. Okay, so this is the first question, and the second question, determine the time when speed is minimum. Okay, so number 1 need to determine velocity acceleration. Number 2 question, determine the time when the speed is the minimum. Okay, so for the velocity, let's say r prime t. Okay, r prime t, so you differentiate t cos 2, you look at the 2t. Okay, 2ti. Okay, plus you differentiate sin minus sin t cos t, so this one t cos t you need to solve using the product rules. So this one t, so yeah, the product rules you need solve for the product rules. Ni product rules. So this one get the answer is the t sin t. Okay, after you selesaikan this one product rules, and then J, okay, plus T cos T K. Okay, this one pun you need to solve using the product rules. Okay, so selesaikan, so you get this one, and then this one equal Vt lah, Vt, so you differentiate Vt, so you can get the answer is the 2i plus T sin T ni product rules so you dapat T cos T plus sin Tj, so you plus minus plus negative T sin T plus cos T. Okay, so this answer for the velocity. Okay, settle soalan number 1, velocity, acceleration, settle. And then question 2, determine the speed. Determine the time when the speed is the minimum. Okay, so we need to find the speed lah. So V, this one lah, V. So 2t cos 2 2t cos 2 2t cos 2 plus T sin T cos 2 plus T cos T kuasa 2. So this one is simplify and then you can get this one 4T kuasa 2. So plus T you keluarkan. So T kuasa 2. T kuasa 2 you keluarkan. So dia akan tinggal sin kuasa 2T plus cos kuasa 2T. So this one you dah tahu equal to 1. Okay, set. So the one dia tinggal 4T square plus T kuasa 2. So 4 tambah 1 dapat 5T square. Okay, so this speed equal 5T square set. Okay, so jangan pandai cancel sini dapatkan 5T. Oh no, jangan pandai-pandai, salah unless this one adalah 25. Okay, barulah boleh use simplify like this. Okay, kalau ni tak boleh. Okay, so the still lagi in the term of the 5T square. Okay, this one adalah velocity. This one adalah speed. Okay, this one adalah speed. Speed equal to 5T square. So the question asks, determine the time. Okay, what is the time when the speed is minimum? So for the, I thought in the secondary or secondary school, you can find the time. What is the time of the speed by you differentiate of the speed. So you need to differentiate of the speed. Okay, differentiate of the speed. Okay, ataupun you differentiate ds speed over dt. So you can determine the critical point. Okay, you can determine critical point when you differentiate this one equal to 0. Okay, so we need to find the critical point. So the critical point represent for the t when speed minimum. So you need to find the critical point to represent. So speed minimum, that means speed equal to 0. Okay, speed equal to 0. Okay, when you differentiate equal to 0, that means speed is the minimum. Differentiate of the velocity, differentiate of the speed, okay, equal to 0 represent for the speed minimum. Okay, ds over dt equal kosong is the critical point. So critical point represent for the minimum speed. Okay, kan kalau you plot speed dengan time. Okay, so let's say you dapat macam ni. So this one represent for the reducing. Okay, the reducing of the speed. So what is the speed is the minimum, so you need to find critical point. Okay, so you differentiate here. Okay, you differentiate dv dt. Okay, differentiate set kuasa 2, so you can get answer is the phi 1 over 2t equal t kuasa 2 1/2. So this one, okay, akan menjadi sama dengan kosong when this one numerator ni equal to kosong. So 5 1/2 t equal to kosong. So t you dapat t equal to kosong. So you dah already know t equal to ni numerator. Numerator atas ni must be kosong lah. Kosong bagi something, dia akan dapat sama dengan kosong. Yang bawah tak boleh kosong the restriction. When you divide by kosong, this one undefined. Okay, so untuk dapatkan dia kosong, so yang atas ni must be equal to 0. So you can determine for the t lah, critical point dekat mana. So critical point for this question is the t equal to 0. So you dah tahulah speed time equal to 0. The speed dia adalah, so speed minimum. Okay, speed minimum. Okay, speed minimum adalah bersamaan dengan kosong lah, 5 kosong, so equal to kosong. Okay, this is the way how you can solve for the motion in the plane. Okay, vector function application for the motion in the plane. Okay, so that's all for the class today. Thank you all.